Everyone. Welcome. Today I would be talking about algorithms. This is a very fantastic subject. However, many students feel very difficulty in understanding this subject. I would try my best to explain a very basic concept in a very simple manner. I hope you would enjoy it. Here we go. Uh, as I always say, algorithms are everywhere. What does it mean? That in everything we can observe algorithms. Whether it is a very simple thing, very simple task, or, you know, in nature, we can observe algorithms in everything. For example, mom cooks food every morning, every evening. She follows a certain algorithm. We go to school, we follow a certain algorithm. For example, ants, you might have seen. Well, there was a recent movie, The Ant-Man. See, ants, they follow a certain algorithm. So algorithms are everywhere. It's just we need to keep our mind open and understand it. So let's say, what is an algorithm? In a simple language, we can say an algorithm is a step-by-step procedure to do a certain task. Or more formally, a procedure which can be executed by a machine. See here, these are not very scientific formal definitions, but these are the basic things to make the subject, understandable in a simple way. For example, if I ask you how do you make a tea, what would be the algorithm to make a tea? What do you think? Well, let's figure it out. What should be the algorithm? What should be the step-by-step procedure to make a tea? So first step, we need to arrange the necessary items. For example, tea bags, milk, sugar, cup, kettle, or anything else you have thought which is different than this, and you make tea regularly. Then number 2 step would be you put some water in the kettle and let it boil. Let's see, let it boil will come a little later. Let's put some water in the kettle first. Then step 3, turn the kettle on. And when you turn the kettle on, water starts boiling. Water starts, warming up. Now step 4, by the time water is, warming up in kettle, you put a tea bag into the cup. Step 5, now you go back and check whether water is in the kettle is boiled or not. If your answer is yes, then what would you do? You will put the water into the cup. If it is not, then you would let it boil. Then step 6 comes when you put the water into the cup. After that, the step 6 comes. Do you need sugar? If your answer is yes, then add the sugar in the cup. Otherwise, go to the next step. Then another question, do you need milk? If you need milk, then add the milk in the cup. If no, then directly go to the next step. Stir it and remove the tea bag from the cup. Now next step would be throw that tea bag in the garbage bin. Step 10, you're done. Tea is ready. See, isn't it very simple? But notice, we are talking here about a detailed step. Why detailed? Because if I ask with a robot or with a computer to do, how to make tea, if I do not specify detailed steps, computer will get confused. It will not do anything. Always remember, computer is a very smart machine, but it is not smarter that it can have, or let me rephrase it, it is a machine which acts on instructions. So if the instructions are smart, it will behave smartly. If instructions are dumb, it will behave very dumb. Always remember that. The same algorithm or the same procedure how to make tea, we can um, draw a pictorial representation in the form of flowchart. How? It is depicted here. How do we do? A flowchart is a pictorial representation of an algorithm. It has boxes, um, a sort of notation, but just for now, uh, just be with me. So in the oval box, which we denote or represent, we put a start. It means that now we are starting this task. Same, step 1, arrange items, tea bags, milk, sugar, then we move on to the step 2, put the water into the kettle. Step 3, turn kettle on. Step 4, put the tea bags into the cup. Now, see, turn the kettle on and then put tea bags into the cup. These can be done in parallel, but we are not talking about here the parallel thing. So let's do step by step in a series. Now after putting the tea bags, we check whether the water is boiled or not. Remember, this step is represented by a diamond box. Why? Because it is a decision box. In a typical flowchart notation, diamond boxes are used to denote a decision, that we have to take a decision at this step. So if our water is boiled and answer is yes, then we move on to the next step. If answer is no, then we just stay in this step, that let the water is boiled. Then after that, when the water is boiled, we put the water into the cup. And then we ask another question, do we need sugar? If our answer is yes, then we move on to the next step, put sugar into the cup. Or if our answer is no, we directly move on to the further step, which is again a diamond box, which asks, do we need milk? And accordingly, on the yes and no answer, we move on to the different steps. And in the end, when we are done, we move on to the another oval box, which says the end of the task. Isn't it interesting? See here, it's a written description for an algorithm or a procedure. Here is a pictorial description. This is a very simple example, so it's easy to understand the concept. As we move on to the complex tasks, we might just end up writing the written description as on this slide, or else we just move on to the next. Or else, I'm sorry, let me rephrase it. For larger programs, it is usually difficult to represent it in a flowchart notation. However, we can break the larger tasks in a smaller task and can represent in a flowchart notation. But once you are an expert, you don't need a flowchart. You just, procedure is in your head and you just come up with the algorithm in a written task manner, like on this slide. Let's move forward. The question comes, why do we need algorithm? That's an interesting question. Well, I would ask, do you need your computer to crash? Of course you wouldn't want that. So why? Why computer will crash? Because the computer doesn't execute a good code. And why it doesn't execute a good code? Because the algorithm which was written in the beginning, upon which the code was written, was poor probably. That's why it crashed. Or maybe some other reason. The key concept or the key idea here is that a good algorithm is a necessary key or is a necessity for efficient, robust programs. A good algorithm or an algorithm shows in a simple language how the program will work. Now, your algorithm is same, but it can be implemented in different languages, and every language has a different construct. Why do we need different languages? Because different languages have different flexibilities and used for different purposes. But the algorithm, the basic underlying principle or the procedure would be same. You may think, or I call it, you may, algorithm is the base pillar of computer science upon which the whole computing industry is built. Isn't it very interesting? Think about it. If there is no algorithm, there is no computer science. There will be no computing industry. These big companies who are engaged in developing software, hardware, won't be there. Computer algorithm is the key. Um, or in other words, it is the base structure in the building. See how important algorithm is? It's very important. So we just love algorithms. You will do good programming. You will become best programmers if your understanding of algorithm is good. Let's move forward. We can classify algorithms in different way. Now this slide here, it just gives an overview about different classifications. We can classify by implementation, we can classify by design paradigms, we can classify by complexity. But here, don't go in details. These are just simply showing that we can design algorithms using different methodologies. It is very simple to understand that you can solve an algebraic equation in different ways, but the end goal would be the same. And also it depends on the complexity. For example, say the T example was simple, but if I say uh, that you need to color the graph, or you need to color the world map um, so that no two adjacent countries have the same color. Think about it, it's a very complex problem. So we use different technique for that. Or for example, some algorithms, we can never get an answer in real time. And for many algorithms, we get answer in real time, but as the size of the problem increases, their runtime is enormously increases. So we need different techniques. Sometimes it's not feasible to get an answer quickly in real time. Or say for example, placement problem, where you need to place certain blocks in a certain area so that the area is minimum. So if it is 5 blocks, you can easily figure it out. But think about if there are a million blocks. See, as the problem size increases, it becomes too difficult. We use heuristic techniques there, for example, simulated annealing. But those are advanced algorithms. Here, the aim of this lecture is to give you basic overview about algorithms. Okay? Do not hesitate to post your questions, ask anything, or if you need tutoring or personal lessons in algorithms subject, feel free to send me an email, and we can do private tutoring. Let's see an example. Suppose if I ask you to find maximum number from a list of positive numbers, right? So what would be our inputs? Our input is a list L, which I say L, or you may say any name, of positive numbers. And what output do we need? We just need the largest number from the list. So let's see what the algorithm is and how the program would be implemented. So in a simple sense, when we design algorithm, we just write simple steps, what the computer is supposed to be doing. So we set n to 0 initially, and then we, we check each number in the list and compare it with n, which is 0. So if the number is greater than n, we set n equal to that number. And then we keep doing this repeated comparing, checking for each number in the list. And in the end, we will get the largest number in the list. How we can represent in a algorithm form? This is a simple C++ implementation where this function findMax takes list as an input and the size of the list. For simplicity, it takes size of the list, but if we want to make it more complex, we can determine the size of the list within the program itself. But for here, we provide the size of the list as an input. Now simply, we set n equal to 0, and then this is the for loop that for I, that's a looping variable, starts from 0 and goes all the way up to the size of the list, and we check each element in the list, compare with n, and if the number is greater than n, then we just simply swap the values of n and that number in the list. And in the end, we just return n, which would be the maximum number. Sounds interesting, isn't it? It's very interesting. It's starting. I hope you enjoyed my little video lecture. Do not forget to subscribe LEPROFESSEUR channel on YouTube. You may send your questions or arrange private tutoring to me. My email hr@leprofesseur.org. Hope to see you again next time. Thank you. Have a great day.